Boyle's law and Charles' law are two gas laws. They can be combined into the ideal gas equation PV equals nRT. The ideal gas equation is helpful when carrying out calculations involving gases. However, this equation and Boyle's and Charles' laws is only completely correct for ideal gases. Most gases do not fit this equation exactly, and they are called real or non-ideal gases. In this lesson, you are going to learn how to use the ideal gas equation in calculations and learn about the behavior of ideal and real gases at different conditions of temperatures and pressures. Look at the two relationships for 1 mole of gas at the top of the screen. One comes from Boyle's law and the other comes from Charles' law. Which relationship is from Boyle's law and which is from Charles' law? Answer: V is proportional to 1 over P is Boyle's law and V is proportional to T is Charles' law. Combining them gives a relationship for 1 mole of gas involving V, T and P. By introducing a constant called the universal gas constant R, an equation called the ideal gas equation can be obtained. PV over T equals R. This can be rearranged as PV equals RT. Drag and drop P, V, R and T on the screen to get the formula for n moles of gas. The value of R you use depends upon the units you have chosen. You must always use the temperature in Kelvin. If you use the International System of Units, SI units, you take R as 8.31 joules per mole per Kelvin. If you use non-SI units, you take R as 0.0821 liter atmosphere per mole per Kelvin. Look at the units for volume and pressure in the boxes at the bottom of the screen. Drag and drop each unit to its correct place in the table. Read the ideal gas equation at the top of the screen. Now drag and drop P, N, R and T to rearrange the ideal gas equation so that V is the subject of the equation. You are going to calculate the volume of 1 mole of gas at 101 kilopascals pressure and 0 degrees Celsius. Enter the correct value in the P box, noting that pressure should be in pascals and not kilopascals. Enter the correct number of moles of gas in the N box. Enter the correct value in the T box, noting that temperature should be on the Kelvin and not the Celsius scale. Enter the correct value in the R box, either 8.31 SI units or 0.0821 non-SI units. Now click Am I correct? To check your values of P, N, T and R. For any values that you got wrong, try again. And finally, drag and drop your values of P, N, T and R into the equation for V and calculate the volume. Click Am I correct? To check your answer. Notice that the answer for volume is in cubic meters, because this is volume in SI units. What is the answer in cubic decimeters? Answer: 22.5 cubic decimeters. The ideal gas equation can be used to calculate the relative molecular mass of a gas. The ideal gas equation is PV equals nRT. The equation linking numbers of moles, N, mass in G, M, and relative molecular mass, Mr, is N equals M over Mr. Drag and drop M, N, Mr to substitute for N in the ideal gas equation. Drag and drop M, R, V, P, and T to rearrange the equation and make Mr the subject. .862 grams of nitrogen gas exerts a pressure of 250 kilopascals in a 300 cubic centimeters vessel at 20 degrees Celsius. You are going to calculate the relative molecular mass of nitrogen. Enter the correct values in the P, V, T, M and R boxes. Hints: pressure should be in pascals and not kilopascals. Note that volume should be in cubic meters. Temperature should be on the Kelvin and not the Celsius scale. R should have the SI units or 0.0821 non-SI units. Now click Am I correct? To check your values of P, V, T, M and R. For any values that you got wrong, try again and then click Am I correct? Finally, drag and drop your values of P, V, T, M and R into the equation for Mr and calculate the relative atomic mass to the nearest whole number. Click Am I correct? To check your answer. The relative atomic mass of nitrogen is 14. What does the answer to the calculation tell you about a nitrogen molecule? Answer: a nitrogen molecule is made up of 2 nitrogen atoms joined together. 14 times 2 equals 28. Summary: the ideal gas equation is PV equals nRT, where P is pressure, V is volume, N is number of moles, T is the Kelvin temperature, and R is the universal gas constant. The value of R depends on the units used. If SI units are used, that is, volume is measured in cubic meters and pressure is measured in pascals, the value of R is 8.31 joules per mole per Kelvin. If non-SI units are used, that is, volume is measured in liters and pressure is measured in atmospheres, the value of R is 0.0821 liters atmosphere per mole per Kelvin. The ideal gas equation can be used to calculate the relative molecular mass of a gas.